Alright, welcome back to more covalent Lewis structures. Let's start out with boron trichloride. So with boron trichloride, we have boron, which is going to have 3 valence electrons, and chlorine, which is going to have 7, but there are 3 of them. So giving us 21 plus 3 is 24 valence electrons. So which of these goes in the middle? I hope you realize boron is the least electronegative, so it goes in the middle and chlorine goes around it. Now let's fill in the octet for chlorine first and see what we get. Alright, we have now placed all of our electrons around the chlorines. So, how many do I have? Do I have any more left? Boron's not happy here. Okay, but boron is a fantastic exception to the octet rule. It doesn't care if its valence isn't full. It's perfectly happy with 6. It's just not as needy as all these other elements, I guess. Same thing for aluminum. Aluminum don't care. Okay, it'll take 6, and it's perfectly fine. Okay, but is chlorine happy? Chlorine has to be happy around that outside. 8, 8, 8, 24 electrons total. Chlorine's happy, boron's satisfied. Okay, therefore it's pretty happy. Now I hope you'll notice that there are trends, meaning if I were to do boron trifluoride, fluorine also has 7. So I could literally just replace every chlorine with fluorines, and it's going to have the exact same Lewis structure, just fluorines in place of it. Okay? And so I hope as you're doing these things, you'll notice trends, like the fact that all of these in group 7 like to have one single bond with a whole bunch of electrons around it. Okay? Kind of as you're doing these Lewis structures, just think about these trends and think about where stuff is in relationship to each other, because the groups are also called families, which means they behave similarly, which means in a Lewis structure, it's very easy to just take one member of the family out and swap it with another one. Okay, so look at these trends as you're doing it. Next, let's try tellurium tetrachloride. So tellurium on the periodic table is 4 down from oxygen, which means it also has 6 valence electrons. And chlorine has 7 valence electrons, but there are 4 of them. So 7 times 4 is 28. Plus 6 gives us 34 valence electrons. What does this guy look like? Well, let's find out. So we've got tellurium in the middle. It's the least electronegative. Then chlorine's around it. Now we need to start putting electrons on. You should notice that pattern that we saw before, where there's a whole bunch of electrons around my chlorines. And now I've completely made chlorine happy. All of my chlorines have a filled octet. Tellurium has a filled octet, so it's happy. But I can't stop there, because I have to make sure that my valence electrons matches my Lewis structure. And it doesn't right now, because 8 times 4 is 32. I have 34 available. Where should I put them? How about around the center? It goes right in the middle. Tellurium is bigger than phosphorus. It can take those extra electrons. Okay, so that's what you're looking at here, and this is your final Lewis structure for our tellurium tetrachloride.